today is to talk about measures of central tendency. So as we know, measures of central tendency includes the mean, the median, and the mode. In our previous lesson, we also talked about the importance of the level of measurement. So as mentioned before, level of measurement is very important in determining for the appropriate measure that you're going to use. So we have here a table that shows now that if your level of measurement is nominal, ordinal, interval, or ratio, what is the most appropriate measure of central tendency? Another term for measure of central tendency is averages. So just to have a review, the mode is the highest frequency. So this is obtained by observation. Just determine what variable or categories is the highest frequency. While for the median, all you need to do is to arrange your data from lowest to highest or highest to lowest, and the middle value is the median. While for the mean, so you have to add all the data and divide it to the total number of item or total number of data. So let's have an example of nominal data. So for example, number one, sex of a group of students in a collaborative learning in physical class. So we have here a table that shows the student 1 to 10 and their sex. So the number of male in this example is 6, while the number of female students is 4. Obviously, the highest is male, so it means that the mode is male. However, if we try to obtain now the median, it is not possible because we cannot arrange sex from lowest to highest or highest to lowest because in the description or definition of our nominal before, it's just simply a categorical without rank. And then, if we will consider now another example, IQ level is an example of ordinal data. So just like example number one, if we are going to observe the highest frequency, so if we count for the number of average, A represents average, double A is above average, and S is superior. If we're going to count for letter A, it is 7, while the number of above average is 3, with 1, 2, 3, 4, 5 superior. So based from that observation, we can again say that the mode in this data is average. While if we're going to report also for the median, in the case of IQ level, so it's also a categorical variable, but it is with rank because we can already arrange this from average to superior or superior to average. So we have here another table that shows that it's already arranged from average to superior. The total number of respondent or student is 15, which means the center is 8. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7. So the center is above average. Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8. So the data here, the median is above average. And then if we're going to compute for the mean, just like sex, we cannot add male plus female, and we cannot also add average plus above average plus average plus average, and so on. So if the data is ordinal, we can only determine the mode and the median, but not the mean. And let's move to another example. So this is example number 3. The data that shows the percentage provided with antenatal care by doctors or nurses. So it's in percentage. So for year 1988 to 1993, it's 83.1. So until this is the data from 1988 to 2013. So by inspection, we cannot see a number that appears two or more or twice or more, so which means there is no highest frequency. This means that there is no mode. However, in case that, for example, we have 283.1, 285.7, 287.6, 291.1, and 295.5, it means that the mode is multimodal and it is all the numbers that appears because they have the same number. So if it appears only once, it we will report it as no modal. But if it appears the same number with all the numbers in the data, like all the numbers appear twice, all the numbers appear thrice. So there's no highest frequency because the frequency of all the data are the same. Then we can say now that the mode is multimodal. And also, if we're going to arrange this from lowest to highest, so from 83.1, 85.7, 87.6, 91.1, 95.5, the middle number is 87.6, so which means that the median is 87.6. If we will compute for the mean, it is possible to compute for the mean because, of course, this is already numerical data. So we can add 83.1 plus 85.7 plus 87.6 plus 91.1 plus 95.5, and this will be divided, the sum will be divided by 5 because we have 5 data, and the answer is 88.6%. So this means that the mean in this data is 88.6%. So let's go back to our checklist. So we have here our table that shows now that if the data is nominal, so the example provided to you is 6, it means that you can get the mode, the highest frequency, and you cannot get the median because nominal data has no rank, and also it's not numerical, so you cannot compute for the mean. The appropriate measure if the data is nominal is mode, because of course you do not have any other option to choose from. While if the data is ordinal, so you are provided with example also, that example is the IQ level. We reported the value, I mean the mode. We also determined the median, but there's no way for us to determine for the mean because we cannot add average plus above average and so on. Between the two, the better measure of central tendency is median because this is actually arranged from the lowest measure to highest measure. So just like in the level of measurement, the lowest measure is nominal and the highest measure is duration. While for the level of measures of central tendency, the lowest is the mode and the highest is the mean. So in the case of the ordinal, since median is better or higher measure, then the more appropriate measure to report is the median. Well, for data that is interval or ratio, we can get the mode, we can get the median, we can also determine the mean, but there is an additional condition here that talks about the normality of the data. If the data is not normally distributed, or in other words, it is skewed, then the measure of central tendency that you will report is the median. While if it is not, then the measure of central tendency that you're going to report is the mean. But by central limit theorem, even if the data is not normally distributed, if it is the number of data is at least 30 or more, we can still use the mean. So I have written here that you will use mean if the data is normally distributed or for at least 30 sample size. But if the data is not normally distributed, then you're going to use median. So let's go back to example number 3. So how to determine now if the data is normally distributed? We actually have several ways to do that. And the first one is we can construct histogram. And if the histogram looks like this, then the data is normally distributed. Or you can compute for the mean, the median, and the mode and determine now, or rather compare now the values. If the values are approximately equal, it is normally distributed. But if the highest value is mean and the lowest is mode, it is positively skewed. The highest value is mode, the lowest value is mean, it is negatively skewed. But anyway, it is not important anymore if it's positively skewed or negatively skewed. The idea here is that if the value that you computed for the mean, the median, and mode are approximately equal, then we can say that the data is normal. However, if it is not, then the data is not normally distributed. And then another way is again also to use Microsoft Excel to compute for kurtosis and skewness. So this is the function for our kurtosis, equal sign kurt, and then just select the data. Or if you will compute for the skewness, equal sign the skewness and also select the data. And to interpret the values, you can simply compare it or use the guide for interpretation that if the kurtosis is between negative 0.5 to 0.5, it means that the data is normal, or the term that can be used is mesokurtic. So mesokurtic is synonymous with the word normal. While if the data now or the computed skewness is between negative 3 to positive 3, it means that the data, or that all values now are also normal. So which means in the computed example here, so the computed value is negative 0.47 and skewness is 0.56. So it's indicated in the interpretation that since the computed kurtosis is negative 0.47 and this is within negative 0.5 to 0.5, then the data is normally distributed, and it is also supported with the value of the skewness, which is within negative 3 to positive 3. Therefore, the appropriate measure for our data is the mean.